It's always interesting, I think, in education when people try and classify topics as being a certain level, like, oh, sequences, that's not a difficult topic, at GCC, for example. But then you get to situations like this where this is a sequences question and it is just so much more difficult just because of the way it's worded, which makes it, which means you basically can't ever classify a topic. You can ask easy questions of it or difficult questions. And this is a difficult question. And the first difficulty is trying to work out what part A is actually talking about. But let's get the sequence written down first of all. So Frere's sequence, it starts with 1, and then each subsequent term is 5 more than the previous term. So this is not too bad. It's just all our numbers that are 1 more than a multiple of 5. Okay, it's going to end in a 1 or a 6. Hilary's sequence, however, starts with A, and then each subsequent term is 3 less than the previous term. So we don't know what A is. But what we do know is that eventually it will become negative. Because the question's asking about terms that are in both sequences. So we can see eventually, like they're not going to have an infinite number of shared terms. We're told that there is at least one number that appears in both sequences. Let C be the smallest of those numbers. Find the possible values of C. So I think a good approach here is just to try some numbers out. Um, so I just went with this. I let A equal 16 because then I'm guaranteed to get 16 in my sequence, and then it would be 13, 10, 7, 4, 1, and it's going to become negative. So I see that I've satisfied this. There's at least one number that appears, at least one number that appears in both sequences. I've actually managed to get two, but here's the key one I'm interested in, the 1 and the 1 here. It's possible that C could equal 1 because let C be the smallest of those numbers. Well, I've got 16 and 1 in this case. It's quite a good example, I think, because I do actually have 2 in this case. I could have started my sequence with 13, actually, and then I would just get the 1 shared number. But in both cases, C equals 1 is a possibility. And here's the thing now, it's only really working through this and thinking about it, you get a bit of a strategy. So for it to be in both sequences, it has to be in Frere's sequence. It's not like I can have 3 in both sequences. 3 is not in Frere's sequence. So I'm answering this question is kind of exploratory way about how you might actually do it if you're answering the question. You might not see the answer straight away. Okay, so how can we get 6 as a possibility? Well, I could let A equal 6. That will give me 6, 3, 0, minus 3. So that would work. That is the smallest shared one. And then, how about 11? Okay, well then let's let A equal 11. I could have just let A equal 1 for the starting one. I just thought, actually, when I read this question originally, I thought it had to have more than one shared one, but because it's at least one, it can include one. A equal 11, then I'm going to get 11, 8, 5. None of these are in that other sequence, 2, minus 1. C can equal 11, so 3 possibilities. All right, what about 16? Well, actually, I already dealt with 16, and here's the thing. When I try and let 16 be in the sequence, I'm because I'm going down by multiples of 3, after 5 terms, I'm going to get to 1. So I can't have C equal to 16. It's 15 more than 6. Sorry, it's 10. Sorry, that's not what I meant. It's 15 more than 1. Sorry. And then 21 is 15 more than 6. And the next term, which will be 26, is 15 more than 11. Because I'm going up in multiples of 5 here and I'm going down in multiples of 3, every 15, they're going to have a shared term. So these are the only possibilities. So C equals 1, 6, or 11. And 16 is 1 plus 15. So 16 cannot be the smallest shared term. And for me, the hard part here was like kind of justifying and explaining why no other number can be the smallest shared term. And I'm taking, a nice bit from the answers here. So let x be a shared term. Then, as we saw from the sequence, the Hillary sequence, x minus 3 is going to be in the sequence, and x minus 6, x minus 9, x minus 12, and x minus 15. And x minus 5, x minus 10, x minus 15 will be in Frere's sequence if x is greater than 15. So x minus 15 also appears in both sequences, and c therefore cannot be bigger than 15. So that's just a little bit more explanation for why, it can't work. We tried 1, 6, and 11. We had a look and saw that 16, because you're counting back. If 16 is in both sequences, then 1 will also be. And this is an algebraic way of generalizing it. If x is a shared term, then we can just keep counting back 3 for Hillary's sequence, and we can count back 5 for Frere's sequence, assuming, I mean, remember it starts at 1, so this is not always the case, but if x is bigger than 15, it works. And so then x minus 15 appears in both sequences, and that means that if x was the smallest shared term, then, well, it kind of couldn't be if x minus 15 is also in the sequence. So c cannot be bigger than 15. I feel like that's enough explanation. I'm happy with that, and I hope you are as well. Right, let's look at part B. Given that there are exactly 100 numbers which appear in both sequences, find the possible values of A. That is the starting number of the second sequence. Now, let's not forget what we've just looked at in part B. We had that the smallest common term was either 1, 6, or 11. So the focus has got to be on this second sequence. And I'm going to start by looking at the term being 1. So that means the last term is 1. So I actually have to almost take this sequence in reverse and write it as dot 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 a minus 9, a minus 6, a minus 3, and a. So if the last common term is 1, then it's going to go 1, 4, 7, 10, and so on. And I'm interested in there being exactly 100 numbers which appear in both sequences. But as we saw in part A, it's actually every 15. Where have I written it? I can't even remember. I talked about it. I don't think I wrote it down. Um, so every 15, you'll get a repetition. And therefore, if I want 100 numbers, then my last term is going to be 1 plus okay, so 16 is going to be the next one that's repeated. It's going to be in both sequences. So you can see it's like I've got this one and it's one lot of 16. So the 100th repeated one is going to be 15 lots of 99 because I've got my first term and there's going to be another 99 terms. I just want to explain that again. So I'm starting, this is how I started the problem. I just looked at the smallest one of the three, where it's the smallest common term to both sequences. I've written the sequence in the opposite order just to kind of help. Okay, it's actually going down, but I've written it like this. And then I want 100 of the numbers to appear in both sequences. I know that every plus 15 they'll be repeated because this one goes up by 3 lots of 5, whereas this one goes down by 5 lots of 3. So I want my starting term, in fact, or a starting term, to be 1 plus 99 lots of 15. And maybe I should have written it that way round. Now, this is going to, 100, the easiest thing to do is find 100 lots of 15, because that's easy, 1,500, and then minus 15. So it's going to be 1 plus 1485. It's going to be 1486. This is going to be a possible value for A. Because then I'm minusing 3 and minusing 3. Okay, I keep going, and across the way I would have these common terms in every minus 15. Now, are there any more that will give me my last common term as 1? And the answer is yes, actually. You have to have a really good understanding of what is going on in this problem. Now, 1, 4, 8, 3. Okay, could it start with that? Could A be equal to that? And then 1, 4, 8, 0. Well, actually, we'll go down to 1, but I don't have that 1486, so there'll actually be 99 common terms here. So that's not going to be a possible value for A. But if I go in the other direction, 1489, then that will take me to 1486, and I'll get the same sequence again. I'll get my 100 shared terms. So this is another possible value. I'm going to underline it, and I'm going to underline that one there. As is 1492 if I started 3 more, because the next one's going to be 1489. And I'm going to keep going until I've got to 15 more than 1486. So 1495, 1498, and then it would be 1501. But at this point, that is 15 more. And so I would actually get 101 shared terms because this would be in the other sequence as well. Remember, because it either has to end in a 1 or a 6. So I reject that one. So for me, it wasn't too bad figuring this out, that actually I just need to add on 99 lots of 15 to my smallest shared term to get a possible value for A. It was quite hard, this bit here, realizing it seems like easy when you're explaining it. Of course, yeah, you just keep adding three, just, all these will also have the same shared terms until you get to plus 15. So we've actually got one, two, three, four, five different values for A. Once we've cracked this, it's actually going to be very similar for 6 and 11. So for 6, I can write it in reverse order. It's going to be 6, 9, 12, and so on. And then this is in reverse order. So my last one is going to be 6 plus 99 lots of 15 again to get my 100 shared terms. And that's just going to be 5 more than what I had here. So 1491. Okay, so another possible value for A. But as before, I can just add on 3 and keep doing that. And at that point, I've actually added on, sorry, that should have been a 6. This is where it breaks because again, I would get 101 shared terms here. So I've got another 5 lots. And then finally, we've got our highest term that can be shared, but but it's the lowest term that is shared, if you know what I mean. It's just the highest out of these three, 11. And it's going to be 11 plus 99 times 15. So 1496. That's going to be a possible value for A. I'm finding them all. Actually, the question just says to find how many there are. And I can see now there's going to be 3 lots of 5. It's going to be 15. And then ask for the smallest and the largest. So you might be able to very quickly figure that out. But I just feel like it's best to find them, like actually find them all. 1499, 1502. Okay, and this one's 15 more, so reject that one. So this was the largest of the values of C, and therefore when I've added on my other 15 lots of 99 and then another 12, I'm going to get my largest possible A as 1508. How many possible values of A are there? 15, because there are 5 lots associated with each one of these values of C. And then the smallest possible value of A is going to be that 1486 because it started with the smallest C and then I'm not adding any more on. Okay, that is it. I've solved this question. I think it's tough personally. I think like going through it and reading this now, it's not so bad, but figuring out to do this is obviously much harder than just like following a solution. So well done if for any attempt you made at this question. Um, we've done part A, and actually part A is absolutely essential to be able to do part B. as with a lot of the questions in these papers, we're actually given a bit of a helping hand to do what is then a much more difficult question. It helps to write this in reverse, think about the smallest term. Um, and then I personally think writing down all 15 here is a good idea. But like I said, you might have been able to spot that, okay, this is clearly going to be the smallest, and then the largest is going to be associated with 11 when we add on the most that we can. And there's clearly going to be 5 associated with each one once you find one lot. But I've found them all.